Hello, I'd like to welcome you to the fourth and final day of our virtual Pig Week. I hope you've been enjoying the daily routines over the last 3 days, and we're going to finish off with a bang here today. We've got a great speaker, Dr. Scott Dee from Pipestone Veterinary Services in the US. The Pipestone Veterinary Services, they were founded back in 1942. They've got 6 clinics scattered around the Midwest, and they've got over 40 veterinarians working with them in their business. Bit of background on Scott. He's obviously a qualified veterinarian. He worked as a swine practitioner for about 12 years in practice in the Midwest, and he was also professor in the vet school at the University of Minnesota, where he worked on PRRS, transmission, and biosecurity. He joined the Pipestone Veterinary Services group in 2011 and has been the director of research in their applied research program, where they in recent years have been looking at the whole area of viral transmission and transport in feed, the whole area of biosecurity around feed, and antimicrobial resistance. So without further ado, I'd like to welcome you, Scott, to Ireland. It's a pity we couldn't have you here in person today, as was intended, but maybe all going well, we'll get you over in 12 time. But to make up, we're going to have you all the way over from Pipestone, and it's 7:30 in the morning, Pipestone. So we appreciate you being with us this early in the day for yourself, Scott. So over to you now to take us through the presentation. As always, you can put your questions for the attendees. You can put your questions in through the Q&A, and Louise Clark, my colleague here, is joining us as well. Louise will facilitate the Q&A at the end of the presentation. So over to you, Scott.
Thank you, Sharon. Good morning from Minnesota. Good afternoon to you in Ireland. And I'm so sorry I could be with you. I have only visited your beautiful country once. And so I was so excited when I got the invitation from Sharon, and I'm so sorry I can't be there. I wish I was for many reasons. One, because we just had about 10 centimeters of snow, which is far too early, even for Minnesotans. You know, Minnesota is right up by Canada. So we're used to snow, but not this early in the year. So we're kind of upset about that. But anyway, forget about my wailing about snow. Let's talk about something which is much more important. Let's talk about African swine fever and other foreign animal diseases. And I know I come from the US and I'm not from Ireland, but I think some of the messages that I'm going to share with you today are important for any country that is free of these diseases, especially ASF. And some of this might be a little bit scary. So I'm looking forward to the discussion, and I'm looking forward to your questions. But I want to raise the awareness of the risk of feed and feed ingredients for moving viruses, not only within a country, but between countries. So with that, we'll get started here. The support of many groups that have worked with me on this project for the last few years, funding agencies, the Foundation for Food and Agricultural Research, the Swine Health Information Center, and many universities that I've collaborated with on this project. So next slide, please. All right, so maybe you folks are having some coffee, maybe you're having a Guinness. If I was there, I'd probably have the Guinness, but let's have a little story. Let's tell a story today. Let's talk about a little introduction to Pipestone. Then let's go into African swine fever. We'll review the virus and talk about China. We're going to talk a lot about China today. And I know ASF is really a continental disease across the world. It's in Europe, it's in Africa, it's also in Asia. And from our perspective, and I think potentially from Ireland's too, understanding what's happening in China is really important. We'll focus on the feed as a risk factor. That's a lot of new information. I'll tell you what we've done so far in North America and maybe give you some ideas of what you can think about in Ireland. Then we'll wrap it up. So some books off the shelf today for this story. Next slide, please. All right, quickly, a little bit about Pipestone. Sharon gave a nice introduction about myself, and with the company I'm in now, as he mentioned, it's a very large group. I think we're one of the larger veterinary organizations in North America. I think we actually have about 45 veterinarians now, and that's where my research division lies, in the veterinary service division you see at the top. We manage what's called the Pipestone system, which is an interesting model. It's 300,000 sows across 75 sow farms. It's the third largest system in the United States. And we don't own the sow farms. Groups of farmers do, but we buy the land, we put up the building, we stock the building, we run the farm, and then the producers pay us per weaned pig that go to their respective wean to finish sites based on their needs. So we kind of oversee everything from the wean to finish side, which is a neat model. We also can manage the grow finish pigs if the producers want us to. Pipestone Grow Finish takes care of that. We've got a nutrition division. We help procurement as well as do formulation and research. We've got a marketing arm where we can contract for the producers if they want. We've got a processing plant we've just added. And then we've got an international initiative that goes into China and Latin America. So we let the producers pick which piece of this they want. They're owners in the sow farm, and they can do everything else by themselves if they want to. But if they want us to take care of various segments from weaning all the way to processing, we can do that. So it's up to them. They can make the decision. Next slide, please. All right, so let's talk about the subject matters today. Let's talk about viruses. They're concerning not only to North America, but obviously also to Ireland. So these are 4 electron micrographs of viruses. The first one up in the upper left-hand corner is foot and mouth disease virus. Right below it is pseudorabies virus or Jeschke's disease virus. Upper right-hand corner is classical swine fever in the red tinge picture. And then right below that is African swine fever, the topic for today. So we're going to focus on that. But the concept of feed as a vehicle to move this African swine fever also pertains to these other viruses, and I'll show you how we figure that out. So next slide, please. We all understand what can happen. You know, we've talked about foot and mouth disease in United Kingdom. We've talked about classical swine fever in Holland. We know the devastation these diseases can have. Next slide, please. They cost a great deal of money. This is some estimates. If any of these viruses got into the US, foot and mouth disease, $12.9 billion would be lost in the first year. Classical swine fever, almost $10 billion the first year. And African swine fever just recently calculated at 16.5 billion in the first year. So obviously our export market would stop immediately on pork. It would depress the prices for pork, obviously. That would also bring down the poultry price, the beef price. It would stop our grain exports. It would actually stop tourism. You know, when I've been reading about these diseases in the United Kingdom or reading about them, FMD or classical swine fever in Holland, it looks like even tourism stops because nobody wants to go there. They're afraid they're going to get contaminated somehow. It seems like, from my readings, is the only thing that rises is the suicide rate. And I've read some really sad articles looking at the effect of these diseases on people, even though they don't infect people. But it looks like it's really tough on the people. So it's a bad situation. Next slide, please. All right, let's talk about the African swine fever virus. I have a colleague named Dr. Gordon Spronk. You see his quote at the bottom. He, in his mind, and he's worked in China quite a bit, he's seen ASF. He considers this the world's worst pig virus. Now, it only infects pigs, that's the good news, but it kills every pig it infects. Our China business unit, when it got ASF, we had over 95% mortality in our wean to finish populations. So of a 2,500 head wean to finish facility, we might end up with 40 live pigs. The rest simply die. It's a terrible situation. So next slide, please. All right, here we go. There we go. There we go. That looks good from my vantage point, hopefully for yours. So let's go ahead to the next slide. And I think we're going to talk a little bit about this. Here it is, movement into Asia. So this is kind of where everything changed. This is when all of a sudden, to us, at least from the United States perspective, the world changed. We knew we had ASF obviously in Africa. We knew it was in Europe. We had seen it migrating eastern to Western Europe. But when it came into Asia, into China specifically, probably came from Russia. In August 3rd, 2018, we learned the news that the Shenyang province there was the first recorded outbreak of ASF, although I believe it had been there for a while. This was the first public notification. You can see from the slide all the spread of this disease across Asia into the Koreas, down into Vietnam and Cambodia, Indonesia, Philippines. It moved very, very quickly throughout the continent of Asia. Okay, next slide. And so we watch what's happening in China very closely. To me, this is the focal point. I know it's important, obviously, to watch what's coming from Eastern Europe to Western Europe. That's moving through a little different model. That's moving, I believe, more through the wild boar. What's happening in China, we also have to keep our eyes on that, because I think that epidemiology is quite different. So I always talk to my colleagues, Dr. Jaros and Spronk, you see noted up there in the upper right-hand corner, what's happening in China? They haven't been there for a little while due to COVID, but they still keep their pulse on what's happening with our business unit there. And basically, China was really hit hard by ASF. The 50 million sows that they had was immediately decreased to about 15 million sows, but now they're rapidly expanding. And the rumor is they might be up to 30 million or more sows in the country. So this is very rapid expansion with ASF negative stock. So keep that important point in mind. Right now, it's very economical to raise pigs in China, big bucks. Oops, sorry, can we go back, please? Weaned pig in China right now, 21-day-old pig can be purchased for a mere price of $250 US with a $40 US cost of production. A gilt, though, that's what's really valuable. Anything that'll breed, independent of quality or health status, other than ASF negative, it has to be ASF negative. But as long as it can breed, it'll go anywhere from $600 US, $700 US or higher. So there's big money you're making in a pig industry now in China. In China, there's no interest to eliminate ASF virus, so there's lots of wild strains still circulating. Vaccines, there's a lot of black market vaccines, the live vaccines, they're not really tested for safety. And so you've got all these negative pigs being shoved back into the system. You've got a wild type virus circulating out of control, and you've got vaccines which are adding more viable virus strains into the population. So I call it the wild, wild east. Now feed, the Chinese are very convinced that feed is the reason why ASF moves around a lot. Obviously people can move it around, pig movement of course, but there's also the risk of feed. They have found the African swine fever virus, the DNA of the virus in the commercial feed system. So they're very paranoid about feed, and they're actually cooking their feed. They're pelleting it up to a very high temperature, you see, for an extended period of time. So they take the feed risk very seriously in China. All right, so why is this important to countries that maybe are an island like Ireland? You think, oh, we're safe. You know, we don't have wild boars. We don't have that kind of thing happening. Same with the U.S. We have wild pigs, but we don't have wild boar. But where I get worried about is how they manage their grain in Asia. So these are pictures of actual places I've been, and I've seen grain harvested from fields and thrown onto roadways, basically to crack it up and process it and to get ready to ship out of the country. So you see the pictures here. When the first time I saw this with my own eyes, I almost passed out. It was incredibly scary to me because you can see the animal contact, the vehicle contact. Talk about a perfect way to contaminate this material with fecal matter, for example, from a pig truck going to market or riding over this grain. And I've seen that before. It's really something different, but this is how they manage grain in Iowa. I call it a Trojan horse because it's like the Greek and Trojan horse story where there were soldiers inside the gift of the horse that was given the kingdom of Troy. This is a gift we're getting from China that I'm not very excited about. It's ASF hidden in this grain. Next slide, please. And there is evidence that the virus is in this material. The Chinese have documented it through sampling. They've gone and sampled the grain on the ground, tested samples by PCR looking for the virus DNA, so to speak, and they found it. They found it in corn, in soy, in rice, wheat, DDGs laying about on the ground. And so it's like a needle in a haystack. The virus is there, and this is what's really scary to me. Next slide, please. Now, they also find the virus basically everywhere they look. I mean, they found it in the feed mill environment. They found it in feed trucks and trailers. They find it in the complete feed in bins on farms. They find it on the people, in their shoes and their hair, and their fresh markets where everyone gathers to buy fresh pork every day. There's plenty of virus in that environment. And I consider it like an atomic bomb going off when a new virus like ASF got into a naive country like China. It used to be naive. It's like there's so much replication of virus, there's so much mortality, there's so much blood loss into the environment, and that's where the virus survives. It's in the blood of the pig. And it's a very stable virus which lives outside the host for many, many months, years if it's cold and frozen. So this is a very stable virus. And so once the environment is seeded down, almost like that neutron atomic bomb cloud you see in the picture there, I think it's almost impossible not to just move this virus around accidentally through the environmental contamination of grain. Next slide. All right, so let's talk about the feed risk. Where did this all begin? Well, my story with it started back in January 2014 with porcine epidemic diarrhea virus. So I'm gonna deviate from ASF, but we're gonna come back to ASF. But I want to tell you the story about how this all started for me as a scientist, and how I discovered the risk of feed for moving viruses about. And there's PED virus right there. PED virus, the US was naive in 2013. It came in from China, and I think I'm quite confident it came in through feed. I'll show you how. Next slide, please. So my first introduction to PED started in January of 2014. With 3 farms, I'm going to tell you a little story about. The farms here are A, B, and C. These farms we manage. They're part of our system. One's in Iowa, one's in Minnesota, one's in South Dakota. There's no common feed mill. They're 3,000 sows in size. They were air filtered. They're basically bulletproof. They've been free of PRRS and mycoplasma and influenza for many years. But all of a sudden, they all had a feed outage. So you can see farm A, the bin ran empty in the West Gestation. A bin ran empty in West Farrowing on farm B, and a bin ran empty in North Gestation and farm C. And then new feed came in. You see that on January 6th, January 8th, and January 9th. So we had this individual bin go empty. We had feed delivered from different mills, but all this feed went into one bin. And then all of a sudden, a few days later, we started seeing cases of vomiting, diarrhea, right in the same set of animals which would have consumed that same feed. So you see the feed outage matches where we saw the index cases in all 3 farms. We diagnosed the disease in a short period of time and actually went into that bin. If you look at that little picture on the bottom, 2 bins there. The right bin was the bin that had run out of feed, and it was feeding these index cases. I went into that bin and I scraped the sides of the bin, collecting some of the dust from the feed that had already been consumed. And that's where I found the virus. That's where I found, as you can see in red there, what we call the cycle threshold, evidence of the viral RNA at a very strong level in that feed bin. So there was evidence of viral RNA in that feed bin on that material that had hung up on the sidewalls of that bin, which had now been consumed by those hungry animals. Now, right next to you see the bin, that was a bin feeding another set of animals, completely healthy, and there was no evidence of virus in that bin. So it was interesting how we focused this down onto one specific bin. Next slide, please. So I started thinking, well, as you know, a PCR test that we ran on this feed, that just shows us whether there was nucleic acid or viral RNA in this case, but I didn't know if it was live. That's another question. So if feed's going to be a risk, we have to see whether the pigs can consume it and become infected. So I took that feed material, that little pan you see there on the floor, and I let these negative pigs eat that feed. And next slide shows you what happened a few days later. These pigs began to have diarrhea, vomiting, and we diagnosed porcine epidemic diarrhea virus in the feces and porcine epidemic diarrhea disease in the intestine. So we proved for the first time that this virus could be transmitted through feed. Next slide, please. I then wanted to know, well, that was complete feed. What about other ingredients? Are there certain ingredients that would support PED virus survival? So next slide. So I got a list of ingredients, and I'll share them with you in a minute, but I put little bits of different ingredients in these little boxes. You can see these little containers in the upper left, and I spiked them with PED. I put the same amount of PED in each one, and I housed them outside. You can see in the bottom there in January in Minnesota. I just tested them over time. What was interesting, on the next slide, I'll show you how long the virus would live in certain ingredients. And so the x-axis are the ingredients that I had used in this experiment. So I'll just read them for you. Soybean meal, that's the first one, SBM. Complete feed, meat and bone meal, red blood cells, DDGs, choice white grease, lysine, methionine, threonine, and choline. Notice that all of those ingredients were able to support virus because the y-axis is showing days post-inoculation. Soybean meal, for example, the virus lived out to 180 days. So I continued to test these ingredients over time, about every 30-day intervals. And soybean meal, my goodness, I don't know why, but this PED virus was living out for 180 days. You can see the other ingredients supported the virus for a shorter period of time, but it was still viable in all those cases. Now, the other ingredients there circled in red with no blue bars, corn, plasma, various proteins, animal protein sources, VTMs, soy oil, etc. No virus at all. Wouldn't even live a day. Not even one day I couldn't find a viable PED virus. In contrast to the green circle here, these ingredients were very protective of the virus. So now we've got complete feed as a vehicle, but it may be because of certain ingredients in that feed. Next slide, please. The next thing we wanted to know was, how did it get into the United States? Because that was a big question. And I went back to my experiences in China and the grain drying. I was starting to wonder, could the virus be in this grain? Could it come into the country that way? Next slide. So I did an experiment that this was important because you can see how much agricultural product we bring into China from the US. Here's some data from 2013 all the way up to middle of 2018. You see, we usually bring in about 2 million metric tons a year of agricultural products from China to the US. And a lot of these products are these grains that we import, which we'll get into more detail in a second. So it's a concern. Next slide, please. So then we wanted to set up a model. I set up an experiment, and this was done in a laboratory where I simulated moving feed from Beijing across the ocean into San Francisco and then up to Des Moines, Iowa. And I set this up just like it would actually happen. So I used the experiment, which is designed around the actual transport period that it would take to go from Beijing to Shanghai to San Francisco to Des Moines, which was 37 days, including all time in port and preparing for embarkation and also for customs. And I put PED virus in several ingredients, and I stored them in an incubator, which would change temperature and relative humidity every day several times to mimic weather conditions over land and over sea. So I kind of wanted to create a crime scene, almost crime scene investigation, try to reproduce the crime. And I tested the feed at various points, as you can see there, and looked for whether the virus was alive. So I did that for several viruses across the Pacific Ocean. And next slide shows you my transatlantic model. At that time, ASF had not been announced in China. ASF was still in Europe. I made a transatlantic model starting in Poland and then going to France, across the Atlantic, entering New York City, and then going to Des Moines, Iowa. Des Moines, Iowa I picked because that's the heart of pig production in the US. And I sampled ASF virus in feed ingredients at these various points. So this was a 30-day journey based on the actual timetable I received from the shipping agency. I asked them the question, if I'm going to model this, how long is it really going to take? And so 37 days across the Pacific Ocean, 30 days across the Atlantic Ocean in total time from point A to point B. Okay, so This was kind of a neat experiment. Again, the crime scene investigation, and we learned some interesting things, as I'll show you in the next slide. So this is a table that we've published, and it's basically showing you which viruses lived or not. So on the left-hand side, you've got the ingredients we use. So these are ingredients there listed that we bring in from China. So you see various soy products, you see DDGs, amino acids and vitamins. We bring a lot of pet food in from China. And then we also bring pork sausage casings in from China. And so all these viruses across the top are the ones I use. So I used the first column, Seneca virus A, which is a good surrogate for foot and mouth disease virus. I actually used the African swine fever virus. I have a colleague in Kansas State University, Dr. Megan Niederwerder, who has the ability to work with ASF in her BSL-3 lab. So we worked with the actual virus. Pseudorabies virus, there's PED. Moving over, that's porcine sapellovirus. There's classical swine fever. There's circle virus. There's PRRS, vesicular stomatitis, and influenza. So lots of viruses, all put in this feed ingredients and then taken across the ocean in our model. So if you look at this chart, every time you see a red box that's got a plus sign in it, that means the virus was alive at the end of the journey. So if we go to ASF, ASF survived in anything with a red box. So it survived in the 3 soy products throughout our 30-day simulation. It did not live in DDGs or lysine. It did survive in choline. It did not in vitamin D, and it survived in everything else. You can see it's very stable in feed. And so you kind of look at some of these viruses are really stable in feed. Seneca as well, it's again the FMD surrogate. Pseudorabies virus, Ojeski's disease. Look at all the red on the one side of the chart and then all the green on the other side. Not all the viruses can live in feed, but some of them can. And if you read across, if you just read across by ingredient, you see that some ingredients are very supportive, and they're those soy products. We'll pay attention to soy a lot today. Soy, to me, is the biggest risk factor. Look how stable many of these viruses are in soy. So this was kind of the first announcement to the world in a published paper using this model that I've tried to describe, that viruses living in feed may be a risk factor for moving viruses around. Okay, next slide. Now, my colleague Megan Niederwerder, as I introduced her virtually to you again at Kansas State University, then going back to ASF, she said, well, that's cool, but can pigs eat feed or drink water contaminated with African swine fever, and can they get infected? And she did that in her biosafety level 3 lab, and she showed that if you take the virus, you put it in feed or water, you let pigs eat it naturally, you can get them infected, especially through water. Water is the dose in the water to infect a pig is extremely low. The feed is a little higher, but really the probability of infection is driven by the frequency of exposure. That is, how many times does the pig eat feed in a day? That's more of a risk factor, not the dose. So it was really interesting to show that I kind of demonstrated transport of the virus in our model, survival over time. Megan actually showed here how the virus is live in the feed and can be infective if eaten. Next slide. So that was a big, oh my gosh. And then Megan also showed with one of her graduate students, Anna Stoyan, that the virus lives a long time in feed. She calculated the half-life, the time it takes for half of the viral product to decay over time. So she used the exact same transatlantic model I talked to you about, put the virus in the various ingredients, ran it for the 30-day period, and measured the half-life. And she found that in 9 of those 14 ingredients, the virus lived on average, the half-life was a 12-day period of time with a range of almost 10 to 14 days. That means it takes 12 days on average for half of the quantity of the virus to decay, which is a long time. And if you take, it lives for 30 days in the model, it lives way beyond 30 days based on this half-life calculation. So it's extremely stable, well documented scientifically. Next slide, please. So now we're connecting the dots. We know that the virus is in the Chinese grain on the ground. We know from my projects that it survives in a simulated transport journey across the ocean. And from Megan's projects, we showed pigs can be infected upon eating. So we're kind of, again, connecting the dots here. Next slide, please. All right, so the next question we had, no, we're getting into some interesting things that may be, I think, applicable to you in Ireland, which you can start to look at nationally, is where, if we, first of all, are we importing anything like this from China? Do we bring in to Ireland? Do you bring in soy-based ingredients? Do you bring in any of these products that we showed the ASF could survive? That's a good thing to ask. We have a website called the U.S. Government Tariff Schedule. It's a public website that tracks all imports into the United States. And we actually designed a program to ask it questions like, okay, how much soy-based product did the U.S. import from ASF positive countries in 2018, 2019? What are the primary ports that these products enter to the United States? Where do they come in? And do these ports change over time? Next slide, please. So this is what we learned. We just had this paper accepted. It's going to come out soon, but it's basically looking at where we get our soy and from African swine fever countries. In 2018, 2019, again, since that was kind of the highlighted time when China reported ASF, we focused our analysis. You see, we bring in soy from the Ukraine, from Russia, from China. All of those are ASF positive countries. And in 2018, we brought in about 100,000 metric tons. And in 2019, same thing, we brought in about 73,000 metric tons. So this program is nice because you can start to figure out kind of, if somebody's shooting a gun at you, it's nice to know where the bullets are coming from. And this kind of helps us focus on what are the countries of high risk for grain imports. Next slide. And to put it in perspective, this is how laughable this whole thing is. And so this slide just shows you in 2018, how much soy did we export from our country? That's the blue part of the circle versus how much we import. That's the little red piece of the pie there. This is a very small amount in perspective to what we export. And it's one of the things that frustrates me that we're still continuing to bring this material in now that we know its potential risk. Next slide. So the other thing we wanted to know was what ports is it coming in? So here's an analysis we ran looking at where does soy come in from China? We looked at 2015 to 2019. We ran the study, metric tons on the y-axis and time on the x-axis. And you see most of our products come in from San Francisco, from China, as you get that blue line there. And you can see the other ports of entry, also Seattle, Washington, and others. And that's the beauty of this program, is you can start to track again where the highest risk of entry is. And I have 2018 and 2019 highlighted there with the red arrow and the green arrow showing the decline. And I asked the US Soy Institute, I said, how come, why did that happen? And they said, that's basically because of the research that's been done that we've reviewed today and the pressure that our industry put on the government to start to reduce the introductions of soy from high-risk countries. And so one of the messages, besides ASF lives in feed ingredients, and certain feed ingredients are very protective, it's important to know where your feed ingredients are coming from, all the way down to what port they might enter, because you can put some pressure as an organization politically on these imports and show a nice decay there in the amount of soy coming in from China. So that's a good outcome from our National Pork Producers Council. However, next slide, please, Siren. This is the same question to Ukraine. Where do soy products come into the US from Ukraine? And you can see it's it's very helter-skelter. It comes into different ports, different years, it bounces all around. China gets all the bad rap, but we have to pay attention to other ASF positive countries too, because here's is not quite as easy to manage this one, because it's not just coming through a small number of ports. But having this ability to analyze these data based on questions, it helps us understand, again, kind of where the bullets are coming from. Next slide. All right, so what do we do about all this? So let me show you a couple of things that the US has done, and because I think these practices are applicable to Ireland too. We've developed, our industry has developed what we call a responsible imports protocol. And this is not a government initiative. This is a policy-based program. This is not a regulatory program, but it's a plan to bring in ingredients that we have to import because we don't make them in the US from China. So how can we do that safely with science? And so you can see some of the questions we start to ask. Where's the ingredient coming from? What is the ingredient that we're talking about? Are there different places, alternatives we can access? What's the virus of concern? Well, it's ASF. Do we know it's half-life in feed? Yes, we do. How long does it take to get the virus from the source country to the mill? Has any mitigation been applied along the way? Has it been heated? Has it been treated? And then what's the storage period we can apply to it? Can we hold the feed ingredients for a period of time at a constant temperature and let the virus decay? Because these viruses won't live in the feed forever unless they're frozen. If they're stored at room temperature, their virus half-life will decay over time. And so we almost put this material now into a quarantine before it comes to the mill. It's a very different way of dealing with feed. We never used to deal with feed this way. We never used to ask these questions. It's almost like breeding stock. It's almost like we do with animal movement now. And it actually does go into a quarantine. I'll show you some pictures. Okay, so next slide, please. So we've got a responsible imports approach here in Pipestone that we use. Starts in China, which I'm showing you here, and I'll show you what we do in the US. So we bring in vitamins and trace minerals for our producers from China because the cost is so much cheaper, and many of these vitamins aren't made in the United States. But what we do is we go to the manufacturing facilities, and that's what I'm showing you here. And in the upper left-hand corner, we basically put a bench there. You can see where if you're going to enter the manufacturing plant, you have to sit on that bench. You have to take your shoes off on the one side, spin around, and then you walk with your stocking feet to that door, and you put on PPE in the cabinet there. So gloves, boots, coveralls, and a mask. And then you can enter what's there. You can see the bagging room right above it to the right. Very nice facility. And then you can see how the bags, the upper right-hand corner, are stored. They're all under plastic now. They're double plastic layers of protection for environmental risk of contamination to try to reduce it. Now, bottom left-hand corner is how the bags used to move to the port. Obviously, lots of opportunity there for environmental contamination. We now move product in one-time use totes. That's what you see the bottom right-hand corner. So the totes are filled, the container is closed and locked at the plant, and it's not opened until we enter the warehouse in Minnesota where this is arriving. So sealed containers with locks and verification, and everything's just locked down now. So no more open air chance of contamination. And we audit these facilities twice a year. We have Chinese PhD nutritionists on our team that go back to these facilities and ask questions to be sure that the procedures and protocols are being followed. Next slide. So the products come over in a container and they come to a warehouse. This is a company called Sam Nutrition. This is a company we work with for our imports from China. It's in Minnesota. And I'll just take you through a little tour. Upper right-hand corner is the warehouse. You see 3 arrows. The red arrow points to the doors where the container enters. So the trucks with the containers back up to that door and the product enters at that time. The yellow door is where the people enter. There is one stairway and door for the driver and one stairway and door for the workers. So separate entry points for people. And then you can see separate exit doors there from the green arrow. That's where the product leaves the warehouse and goes to the mills after it's gone through, well, how I'll explain the quarantine. So right below that, you'll see a little yellow and black pan. That's the doorway that the driver will enter when he comes up his stairway. And he'll step in, that's a foot bath with disinfectant. And he'll step in that. And there, right below that picture, you see a book. That's a sign-in book. Just like you have on a farm, you have to sign in to this warehouse. And you see in the upper middle picture there, that's where the driver goes. You can see that there's a little boot path. He steps up to the table, he signs in. That's as far as the driver gets to go. Right below that center picture is the warehouse. You see the products are all nicely bagged and organized. Upper right-hand corner is the quarantine room. So the products, once they come off the container, they go into a quarantine room, an all in, all out 30-day quarantine where the products stay by themselves for 30 days at 20 degrees Celsius. So it's just like a quarantine for animals. And this quarantine has a door. You can see it's shut in the bottom right-hand corner. And the products, we fill up that room, the door closes and no one goes in there until the 30 days are over. If you have to enter the quarantine, you have to put on personal protective equipment again, boots, coveralls, gloves, etc. if you're going to enter that quarantine, but we try to restrict that. So it's just like bringing in pigs from a breeding company. It's a very different way to handle feed. Next slide. All right. So the other thing we've done is we've studied, are there certain additives we can put in the feed to reduce viral survival? And this is a paper I just published where I wanted to see if certain additives actually reduce viral survival, kind of break the virus down. And so I conducted a study at our biosafety level 2 facility you see in the corner there. This is a research facility we built. It's got 6 independent rooms with independent air spaces, air filtered in and out. You enter through the entryway we've discussed with a boot bench, PPE, and then into the pig room, and then out a separate door. You shower into each of the rooms. There's 100 pigs in the room. Each room has its own feed bin. So we can put treated feed and non-treated feed in these bins and then let the pigs consume the feed naturally and see if there's any difference between the treated feed and the non-treated feed. So next slide. Now we contaminate the feed. Oh, I'm sorry. Let's talk about first of all, the mitigants. The mitigants we've tested. These are products that are on the market in the United States. There's all sorts of different products here. There's acids, there's medium chain fatty acids, there's formaldehyde-based products, there's essential oils. You can see a long list of companies that I worked with that wanted to bring their product in to test in my model. And so you can just kind of, some of those, I'm not sure if many of these companies or products are available in Ireland, but it'd be interesting to see if you've got some similar products, at least chemistry-wise, that are conducive to killing viruses. I've got a couple starred here. The one you see, the Alltech Guardian with a red star. I developed that product, so I have a conflict of interest to disclose, just so for transparency. And then you see the Cargill Vigilex product that's got 2 red stars. All these companies brought money and product to the table except for them. We wanted to test the product anyway, so some producer clients of mine paid for the costs of testing that product, what's called Vigilex, because they were using it in their system. So I want to credit all the other companies who did pay, and then just let you know there was one that did not. Okay, so we mix up the feed with a mitigant. Next slide, please. Now, how are we going to challenge the feed? How are we going to actually put viruses in the feed? Now, I can't work with ASF virus in this model. It's only BSL-2. But I can work with PRRS, I can work with PD, and I can work with Seneca. That's SVA there. Seneca, remember, is a cousin to foot and mouth. So I took these viruses and I froze them in an ice block. And basically it's a 454 gram block of ice you see there. So next slide, I would actually climb up the walls of the ladder into the bin, and I drop the block into the bin. So there's several thousand pounds of feed in these bins. I drop the block. I let the viruses kind of then melt into the feed, and the feed then gets augured into the facility. The pigs consume the feed through natural feeding behavior. We measure whether the viruses entered the room, whether the pigs got infected, whether they showed clinical signs of either PRRS, PED, or Seneca, and we measure performance. Next slide, please. So this is one experiment I'm just going to show you. We did multiple experiments. Remember that the barn has 6 rooms, and so this is what we call experiment 5. Experiment 5 involved 5 different products. You can see listed there. pH source, that's a fumaric acid. You see the inclusion rate. DOFIT, that's medium chain fatty acid. Dual Defender is essential oil base. First Protect is essential oil and medium chain. And then Vigilex, I'm not sure what it is because the company didn't really tell me much about it. Again, that's the product that we paid for ourselves. Now, we always have a control group in one of the rooms. These are pigs eating feed that's not treated, okay? And so then we measure to see what happened. And here I'm showing you average daily gain throughout the experimental period and mortality. So you see there was some big differences in how some of the mitigants performed. So the first 4 mitigants did very well. There was no statistical difference in gain across pig performance, and there was basically no difference in mortality. But you can see the Vigilex product really was no different than the positive control. So they were, the positive control and this particular mitigant were significantly different than the rest. So it allows us then to really evaluate, can a mitigant reduce the risk of viral contamination of feed? Can it protect the pigs? Can it improve performance? And 14 of the 15 products we tested, yes, the answer was the same. Mitigants were very protective. Next slide, please. So if we just, I'll show you the 5 experiments in looking at just average daily gain of the treatments versus controls. And that little plot there on the right is called a forest plot, and you see the 0 line, and everything to the left, you see the 5 black boxes. That's really the average daily gains of the treatments versus the mitigants. So everything to the right of that 0 line favors the use of a mitigant as it pertains to average daily gain. So in all 5 experiments across everything we tested, you can see there was a strong advantage for using a mitigant in regards to pig health and performance. Okay, next slide, please. All right, so across that, all of that work, you know, what's happened in the US? Have we made any progress? Well, actually, the first progress happened in Canada. At the governance level, the Canadian Food Inspection Agency set up a responsible imports program that was nationally directed, policy-based, but directed by the government. So when product comes in from African swine fever countries into Canada, they go into basically holding zones where they don't move into millings for a 30-day period, similar to I showed you for our Pipestone. So that's working nicely at the country level in Canada. Great example of what that country did. Our responsible imports idea, it's been the policy for that has been approved at our National Pork Forum in 2020. And so the producers in the industry are strongly behind this. And many companies across the United States have set this up. And they've even, our National Pork Producers Council, looking at it from the collective industry level, wrote a letter to our Secretary of Agriculture, Sonny Perdue, signed by all 31 state and national organizations of pork producers, saying this business about bringing in high-risk products, soy-based product from China has to stop. We have to do something about this. And so the producers industry is united. They're pushing the government to try to make something happen. Next slide. So the work's had some impact, I'm very happy to say. And this is my last slide, and I really want to, again, drive home the importance of this information, not just for the US, but for Ireland, because hopefully I've showed you that there's a lot of scientific data now that's been published that shows that certain feed ingredients like soy can support viral survival. And there's options now. We know what we can do. We can hold it, we can store it, we can treat it with mitigants, we can try to reduce viral survival. This information has really helped, it's changed behavior at the level of the veterinary profession. The veterinarians are concerned about this, the producers are concerned about this. Our government, no, we have not made any change at the federal level, which is very frustrating, which is kind of par for the course usually, especially with our government these days. So, 3 take-home points for you. 1, viruses live in feed. Number 2, know where your feed ingredients are coming from. Where are your imports coming from? If you are bringing in imports, are they coming in from African swine fever virus positive countries? And then I hope you all start thinking about, maybe I need to make a feed biosecurity plan for myself at my farm, working with my mill, and then collectively as an organization, what's the national plan for Ireland? What can the industry do to lead this charge to try to protect the country as a collective body similar to our National Pork Producers Council has done. So Sarah, and that's my presentation. Thank you for running the slides, and I'm happy to take any questions that the audience might have. I hope you've enjoyed this. I hope it's kept you focused, and maybe you learned something new today that you hadn't thought about before in regards to biosecurity of not just your farm, but of your country.